have velocity, which is modeled by this equation, which is a quadratic. A, B, and C are constants. The car passes P at time t equals 0 with velocity 8. State the value of C. So that means I can just substitute t equals 0 in to here. Actually, all these are going to cancel out. A times 0 squared plus B times 0 is 0. Oh, sorry, except the C, which is just going to sit there. So it's going to be 8 is equal to C. So I might just add that, update it to this. Right, there we go. Right, we're now told that the car passes Q at time t equals 5, and at that instant its deceleration is 0.12 meters per second squared. And it passes R at time t equals 18 with velocity 2.96. Okay, let's get this information down then. So I'm going to go for deceleration to start with. I need to work out what the acceleration is. That is, okay, but it's a varying acceleration because v is dependent on t squared. This is actually a variable acceleration question, so I need to find dv by dt. And that's going to be 2at, I'm differentiating here, plus b. So that means, okay, because it's deceleration, then we're going to get minus 0.12 when t is equal to 5, so it's going to be 10a plus b. And you can see where this is headed. We're going to generate some simultaneous equations. I've got a and b, but I can't find it at the moment. And then the car passes r at t equals 18 with velocity 2.96. So 2.96 is going to equal 18 squared. (324) A plus 18b plus 8. Right, this is pretty well set up now, so I'm just going to write 10a plus b is minus 0.12. And then I'm going to subtract, I'm going to do 2.96 minus 8. So minus 5.04. Okay, this is typically how you set up simultaneous equations when you're using elimination. This is a mechanics paper, so we don't need to show any working. We can just use the simultaneous equations function. Here we go, two unknowns. So x is going to be our a. Right, so a is minus 0.02. I think I'll stick with decimals rather than fractions. And then b is 0.08. Okay, and at this point, I think I'm just going to update it again. So we've got minus 0.02 t squared plus 0.08 t plus 8. Finally, we're asked to find to the nearest meter the distance between points P and R. So that is when time is 0 and when time is 5. So this is going to involve an integration, but it's actually going to be important to think about the nature of the curve. If it sort of did this kind of thing, then when you integrate and you get this, you get like the displacement, you would end up adding a positive and a negative area, and you wouldn't get the total distance. We'd actually have to make this one positive and then add it on. So we just need to consider what the curve looks like. Well, we know it's when t is 0, we've got 8, and we know it's a negative quadratic, so maybe it's sort of on the way up and coming back down. We don't know that for sure, but it is going to go below the axis at some point. Um, but, right, we're told when t is 18, the velocity is 2.96. So it's still positive at that point. Naturally, what that means is that I'm not going to be worried about finding negative areas here that will mess the displacement up. In fact, if you solve the quadratic, find the roots, you'll find that this is actually 22. I'll just do that here. Sorry. So get the equation, polynomial. So we get about 22.099, and the other one is minus 18. And you can even get, not that it matters, you can see that the maximum is actually at 2. So the way I drew it was pretty accurate, but that's not going to be important here. But so I think you get away with it here. Like you might easily go through this question and simply integrate, especially because it's 2 marks. But from a good practice point of view, you should definitely consider the curve whenever you're asked about the distance um, of how far it's traveling, just in case it goes below the axis. Therefore, I've got an integral from time is equal to 0 up to 18 of the velocity. I should have said that. That's how we're going to get the velocity. It's the area under the graph, so it's the integral of this. But again, because this is mechanics and everything, we don't need to show any more working. It's only 2 marks. Instead, just use this little function here. You definitely don't want to really time like actually integrating it by hand. Sorry, that was a mistake. That should be squared. Okay, 118.08. So to the nearest meter, 118 meters. Nice one.